These days now we will solve a problem involving circle. So the problem is a road with two lanes goes through a semicircular tunnel with a radius of 7 meters. Each lane of the road is 7 meters wide. So how high is the tunnel at the edge of each lane? So that's what we are going to solve. So I've already created and substitute all the given problem, which is the radius of the semicircular tunnel is 7 meter. And the width of each lane of the road is 5 meter. So here's the radius, 7 meter. Here is the width of each lane. So lane 1, lane 2, 5 meter, 5 meter. Now, excuse me. So now, here we have the measures of each lane of the road, which I explained just now, 7, 5, 5 meter. Since we're looking for the height of the tunnel at the edge of each lane, it is essential also to put it in our illustration, which is this lane here, both sides. These are the purple lines here. It represents the edge of each lane, the height of the tunnel at the edge of each lane, which I mean. Since the circle is a symmetric figure, we can say that these two lines are equal in length. The height or the length of these two lines is what we are looking for. Now, to find the height of the tunnel at the edge of each lane, we will determine the point that is at the top of the height of the tunnel at the edge of each lane. You can see either the point is located at quadrant 1, quadrant 2. Let's this represent the point as point P, X, Y in parentheses, which the Y in the point X, all X and Y serves as the height of the tunnel at the edge of each lane. Now, we can identify the value of X, the X value of point P, X, and Y by using the given information from the problem. Since the center of the circle is at the origin here, then we can easily count how many places are there between the y-axis and the height of a tunnel at the edge of each lane. From the problem, it states that the width of each lane of the road is 5 meters. So let's assume 5 meters. 5 meters. Since the point P, X, and Y is aligned at the edge of the road, then we can say that the X value of P, X, and Y is 5 meters. Therefore, we have the point 10 here. 10 and Y. What left to do is to find the value of Y. Remember that the equation of a circle in standard form is x minus h raised to 2 plus y minus k raised to 2 is equals to r raised to 2. Now, the variables are h, k, r, and x, where hk is the center of the circle, r is the radius, and x is the value of any point in the circle. Now, our center is plotted at the origin. With this, our center hk is 0, 0, which h is equals to 0, k is equals to 0. Now, the height of a semicircular tunnel is 7 meters. Using our illustration, this implies that the radius of the circle in our problem is 7 meters. Therefore, r is equals to 7. Now, we determine from our illustration that the value of x that we will use is 5. Therefore, x is equals to 5. To sum up it all the values that we will substitute to the equation of a circle are the following, which h is equals to 0, k is equals to 0, r is equals to 7, x is equals to 5. Now, to determine the how high is the tunnel at the edge of each lane, we will first substitute what the values of this into the standard form of equation of a circle. So, since h is equals to 0, we will denote this as 0. So, x minus the 0 raised to 2 plus, we need to also substitute this in this equation. Is equals to y minus 0 raised to 2 is equals to, our radius is 7 raised to 2. Now, we will simplify. Since 0 times 0 is 0, we will just write x is raised to 2. And same as this second. Y is raised to 2 is equals to 7 times 7 is 49. Now we will use the value 5 to substitute in this equation to find the height of the tunnel at the edge of each lane. So, 5 raised to 2 plus y raised to 2 is equals to 49. So, 5 times 5 is equals to 25 plus y raised to 2 is equals to 49. Now, since we're solving for y, we will put this number, we will transpose 25 here at the right side. Now, it is equals to y raised to 2 is equals to 49 minus 25. Why it became negative? Because 25 here is on the left side is positive. Now, when we transpose it here to the right side, it will be negative. So now, 49 minus 25 is equals to 24. But we're not done yet. Since y here still has raised to 2. Now, to cancel it out, we will square root it. Now, y raised to 2 square root is equals to 24, the square root of 24. Now, to cancel the square root out, this exponent, we will get y is equals to 4.8989, or simply as 4.899 meters. So, go back here. So, we already determined we already determined how high is the tunnel at the edge of each lane, which is, since y equals to 4.899 meter, then this is the height of the tunnel at the edge of each lane. Therefore, the height of the tunnel at each lane is 4.899 meter. Now, here we have it. It is all complete. Radius, meter, and the height of the tunnel at the edge of each lane is 4.899 meter.